Here are our quiz 4 solutions. The first problem, we're given a couple of residual plots and asked to say which is which. So what heteroscedasticity is non-constant variance. So the idea is residual plots tell you how far away, how big your residuals are, how far away from the predicted value your observed value was. So over here, if you note, these spread out a whole lot more because these values are further away from predicted as these are. So what's going on is we have more variance over here than we do have over here. In other words, heteroscedasticity comes from B. Pattern residuals is this guy when you kind of have this pattern going on here. These are below, the residuals are negative, and then the residuals are positive, and then negative again. You have this pattern going on with your residuals. That's A. And then, okay, which of these indicates nonlinear regression may be appropriate, and which has limited prediction for large values of the explanatory variable. This is A, and this is B. The reason why, okay, nonlinear regression may be appropriate in this case because this pattern of residuals is kind of telling us that the line that we fit was above and then below and then above kind of the actual value. So when you have this pattern residuals, it turns out that you shouldn't have used linear regression. You should use nonlinear regression. In this class, we don't learn any nonlinear regression, just that it exists. And this one is B because when your variance gets really big, way out here, your predictions are kind of all over the place. So if your explanatory variable is really big, then you can't use a line that much. The points are all over the place, so it has limited prediction value. Okay, anyways, the second one, we're given information, snowfall and number of accidents, and we're asked to determine which is the explanatory variable and which is the response variable. So snowfall is explanatory, and accidents is response. And that is because snowfall causes accidents, not the other way around. Accidents don't cause snowfall. Right, so this is the kind of the cause and the effect. Okay, calculate the least square regression line. I think the easiest way to do that is to use your calculator. If you go stat, calc, lin, reg, ax plus b, what your calculator will spit out is that a equals 5.8 and b equals negative 1.2. So our least squared regression line is y hat is equal to 5.8x minus 1.2. And to interpret this, what this is saying is that if it doesn't snow at all, we expect negative 1.2 accidents, which doesn't really make sense. Maybe you could throw a big question mark there. And what this is, our slope here, is kind of saying for every additional, what are these, feet of snow? I wonder if I said inches. For every additional inch of snow, we expect 5.8 more accidents. Alrighty, so there's your regression line and its interpretation. Create a scatter plot and graph the regression line on that plot. Alright, I'll do that. Let's see, we want to have our explanatory variable down here, which is snowfall, and our response variable up here, which are accidents. And then you just go and plot all the points. So the first point is at 318. Well, let's see. Snowfall goes from 0 to 10. Accidents go from up to about, 65. So we can create 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we want to go up to 65. So 10, 20, 30, 40, 50, 60, 70. And then plot each of these points. So the first one is at 3, 18. So 1, 2, 3, 18. And I'll pause it and put the rest of the points in. Here's your scatter plot. Here's all of our data points. And now we want to draw this line. See, it has a y-intercept of negative 1.2. So let's see, maybe I'll draw the line in a different color here. Negative 1.2 is just barely below our axis here, so right around there. And our slope is 5.8. So when you go over by 10, you should go up by 58. So almost 60. Let's see, 10, 20, 30, 40, 50, 60, 58 would be right in there. The other point is right around there. And I'll connect those with as straight of a line as I can draw. That's not too bad. So here's a scatter plot. Here's my least squared regression line. Calculate the residual of this observation. Okay, so what we need there is maybe residual is equal to y minus y hat. So the y value is 18, and y hat we can calculate. And the way we calculate is we can use our least squared regression line. But instead of putting in x, we can put in 3. So 5.8 times 3 is 17.4. And from that, subtract 1.2 and get 16.2. So our residual is 1.8. Doesn't say to interpret it, so we don't have to. But the idea is we would have predicted 16.2 accidents. We actually had 18, so we had 1.8 more than we predicted. But I suppose that is the end of the quiz.